Here is the simulation for our ALU that receives feedback, and it operates similarly to our first ALU, where if the selector value is 0, you're going to AND the two. If it's 1, you're going to OR them. If it's 2, you're going to XOR them. And if it's 3, then you're going to NOR them. This is our ALU. And this is our FSM. The only difference now is that it receives feedback. So when the reset is on, then we are going to be our current state is going to be set to 0. Else, our current state is going to be set to our next state. And then once we go into the next process, our feedback and our current state will be checked. So when our current state is going to be 0, starting the finite state machine sequence, we check the most significant bit, and we see if it is going to be a 1, and that's based off of our output from our ALU. If it's a 1, then we're going to send a 0, 1 to our select function, which is going to be the OR operation. And if it is a 0, then we're going to send a select value of 0, 0, which is our AND operation. Else, our next state will be 0, and it'll just continue to loop through. And here is our test bench. We changed the values that we were working on. We're working with 0, 1, 1, 0 and 1, 0, 1, 1, and also 1, 1, 0, 1, as well as 8. And here's our top module connected. Check out our wavelength. We are going to be ORing our first one. And remember, when we get a 1 as our third most bit, or our most significant bit, we're going to be ORing it. So 1 and 0, you're going to get a 1. 0 and 0, you're going to get 0. 1 and 0, you're going to get 1. And 1 and 1, you're going to 1. And because the first one is a 1, it means we're going to OR the next one. And so then we are going to be ORing these two, because our last one was a 1. So 0 and 1 is going to be 1, 1 and 1 is going to be 1, 1 and 0 is going to be 1, and 0 and 1 is going to be 1. So if we progress through, we know that our first one is going to be ORed as well. And you're going to get 1 and 0 is 1, 0 and 0 is 0, 0 is 1, and 1 and 1 is 1.